Okay, for this position, velocity, and acceleration section, okay, we're looking at the graph to find the values. Okay, this, it tells us, is a velocity graph. So these are they're a bunch of linear functions, right? A piecewise linear function. So all of these are straight lines. There's no curves to them. So we can pretty much tell exactly what the y values are, or the velocity, by looking at your numbers on your table right here, or rather from the graph. Okay, so the first question is a pretty interesting one. It asks us, at what values of t does the particle have no acceleration? Okay, no acceleration is different from zero acceleration. Okay, zero is an actual quantifiable number. No is not. Okay? Nope. So we're looking for when the derivative of your velocity is undefined, or is indifferentiable. Right? So we're looking for when the velocity is undefined. Okay, because acceleration is the derivative of the velocity, or the slope of the velocity in this case. Okay, and it happens to be undefined. Sorry, I didn't spell that very well. This is not an I before E thing. So we're looking at where all of the cusps, or the hard turns, are. Okay, so there is a cusp here. There is a cusp there. There's a cusp here. And there is a cusp. Yes, a hard turn, or a V, like a cusp.
So the slope is undefined at those spots, right?
Okay, the slope is undifferentiable. Sorry, the derivative is, the function is not differentiable where there is a cusp. Okay, not differentiable. Okay, and if it's not differentiable, then there is no acceleration, right? It's undefined. So at these points, t equals 1. So here's your t value. T equals 1. And then again at 3, there's another cusp. And again at 6, there's another cusp. And again at 8. Okay, so these are the 4 places here, because your graph has a cusp where your function is not differentiable. Okay, number 2, express the acceleration as a piecewise defined function. So remember, acceleration is the slope of the velocity. So we're going to write down all the slopes of these lines. Okay, all of the slopes. So let's start at the first one. So our acceleration, a of t, okay, is a big piecewise function. So first we look at this part. What's the acceleration here? The slope of this line is up 3 over 1, right? We just have to count up 3 over 1. So it has a slope of 3 between 0 and 1 second. Okay, and then we have over 2 and down 6. So down 6 over 2 is negative 3 between 1 and 3 seconds. We have a negative, right? That's this part. This is a negative 3 slope from there to there. Okay, moving on. What's our next slope? Looks like it's 0, right? We have 0 between the t values of 3 and 6. Okay, and then we have a slope of
It's the same as the other one.
positive 3 between 6 and 8. So up 6 over 2.
It's the same as the other one.
Up 6 over 2. And then our last slope over here is down 3, right 2. So negative 3 halves between 8 and 10. Okay, so there is the piecewise function that tells us what all the slopes are. Acceleration is the slope of your velocity, so we're looking for the slope of all of those line segments. Okay, now our next question is about one of our commandments. When is the particle moving to the right? That happens when our velocity is greater than 0. Okay, so greater than 0 from a graph means everything above the x-axis. Everything above the x-axis is where our velocity is positive. So there are, 2 intervals there where the velocity is positive? Okay, on the interval 0 to 2 and 7 to 10. Okay, because the velocity is greater than 0, our line is above the x-axis. Okay, all those lines are above the x-axis. And guess where it's moving to the left? When your velocity is below the x-axis or your velocity is negative. Okay, so when your velocity is negative, and this is not like formal writing, okay, we would say that the particle is moving to the right on the interval of 0 to 2 and 7 to 10.
Instead of just saying it's greater than 0, less than 0?
Right, because the velocity is greater than 0. Right? This is the y. This is our y, right, the justify your answer part. Because the velocity is positive, the particle is moving to the right. And here, because the velocity is less than 0, the particle is moving to the left. So for AP, you want to write incomplete sentences, right, to be able to justify your statements with some calculus. Is moving left on the interval from 2 to 7. Okay, that's where the graph is below your x-axis, where your velocities are negative. Negative velocities. Okay, so now it says find the average acceleration. So average acceleration, we are trying to find a slope. Okay, a slope of our line. So we're going to use the slope formula. So slope is velocity at 8 minus velocity of 1 divided by 8 minus 1. Okay, so we're using an average rate of change formula in order to find out the average acceleration on the closed interval from 1 to 8. Okay, so here's where we go to our table, or rather to our graph. What's the velocity when at time 8? The velocity at time 8 is 3, because the y value up here is 3 when our time equals 8. And at 1, what's the velocity at 1?
3.
The velocity is also 3. That's the y value, right? This is a time/velocity. So we have time as your x and the velocity as your y. Okay, so let's see. We have 3 minus 3 over 7, which is 0 over 7. So our average acceleration, right, not the acceleration at any given point, but the average acceleration is 0. And the units are meters per second squared. Okay, so average acceleration is found by this slope formula. Okay, here we have another question about speed. Okay, and this is, of course, using one of the commandments also about speed. So, speeding up, the speed is increasing when the velocity and the acceleration have the same sign. Okay, so we're going to check the signs of all these things. It's speeding up when they're the same. Either both positive values or either both negative values. Okay, and likewise, your particle is decelerating, or rather speeding down, slowing down, when your signs are different. So when your acceleration and your velocity have different signs, your acceleration is slowing down, right? You are accelerating in a negative. So let's see, different signs. Okay, so let's come up here and let's see what's going on. Okay, so we're going to take a break for a moment and look at this. Okay, so each of these sections, let's look at them. What about here? What can we say about the velocity between 0 and 1? The velocity is greater than 0, right? The velocity is positive because it's above the x-axis. And what can we say about the acceleration? It is also positive. Okay, so between 0 and 1, our graph is speeding up, right? Because velocity and acceleration have the same sign. Okay, they have the same sign. So now let's check over here. What's happening on this portion of our graph?
But it's just speeding up.
Okay, velocity is positive, But what about acceleration? Is negative. The slope of this line is negative. So between 1 and 2, we are our speed is decreasing. Our speed is decreasing. Okay, now let's look at another interval. How about from 2 to 3? Down here, our velocity is negative, but our acceleration is also negative. So between 2 and 3, our speed is increasing because our signs are the same. They're both negative. Okay, so let's look. That one should be orange, right? Orange is a increasing speed between 2 and 3. Okay, so how about between 3 and 6? We have velocity that is
It's negative.
negative, right? It's less than 0. And what about acceleration? The acceleration equals 0. So is 0 and negative the same sign?
No.
No, it is not the same sign. So between here, it should be decreasing in speed. The speed is decreasing through there.
I see what we're doing. We're just matching.
Okay, we are just matching them up. So let's look at our next section. Velocity here is
Velocity is positive.
negative because it's below the x-axis. But acceleration is positive because the slope of that line is positive.
Wait, from where? From 6 to 8?
So from 6 to 7, from 6 to 7,
Still negative, but
Oh,
is
is
this one up the
Are we doing each one?
Yeah.
we are looking at every interval of change.
We're
Yes.
not going off the whole line, we're going off like 1 to 2.
We're going from where the velocity changes. Yes. We're looking at different velocities. Okay, so let's look at our next little interval. What about from 7 to 8? From 7 to 8, velocity is above the x-axis, so velocity is positive, and our derivative has a slope of 3, so it's once again going to be speeding up between 7 and 8. And then our last spot here, it looks like we're going to be slowing down. We have a positive velocity, but we have a negative acceleration. So we're going to be slowing down on this interval. Okay, so you take all these intervals where they're increasing or decreasing, right? Your speed is increasing when the acceleration and the velocity have the same sign, and your speed is decreasing when your velocity and your acceleration have different signs. So same sign as all the orange, okay, all these orange intervals, and the white intervals are where this thing is slowing down, where the speed is decreasing. Okay, so it's important to know about speed. If your signs are the same, you're increasing. If your signs are different, you're decreasing.